On question 15, we have another numerical problem. So let's approach that. The difference, remember, difference is the answer to a subtraction problem. So I'm going to subtract this time of two numbers is 5. I'll call the first number x, the second number y. So I'll go x minus y equals 5. And then 5 times the lesser number, and since we're subtracting, the lesser number is y, isn't it? So I'll go 5y minus the greater number minus x equals 9. And if we flip those around so they're in columns, I think it might be easier to solve by elimination, but we'll see. So x minus y equals 5. Negative x plus 5y equals 9. Notice that one works out really nice when I put them in columns because my x's cancel. So then negative y plus 5y is 4y. 5 plus 9 is 14. Oh, I get a decimal here, don't I? So y is going to give me 7 halves. Now if you write that as 3.5, I won't care, but we'll put it as 7 halves. So then let's use that to solve the other one. I'll use the first one because x and y are kind of nice numbers there. So x minus 7 halves equals 5. So let's get rid of the fractions. And my first parenthesis does not like to write when I draw it. So then 2x minus 7 equals 10. Add 7 to both sides. 2x equals 17. I'll divide by 2. So x is 17 over 2. So my two numbers are 17 over 2 and 7 over 2. And there's your answer. Now on number 16, we actually have an application problem, don't we? And since we have an application problem, that might be one that's set up for graphing, because we probably won't have to worry about weird numbers with an application problem. But if we do, we'll have to go back and do it a different way. We got trail mix that costs $2.45 per pound is mixed with trail mix that costs $2.30 per pound. How much of each type of trail mix will be used to have 30 pounds? There's my first equation. My first equation is going to be just dealing with the total trail mix we have. Since I'm going to graph it, I'm going to call one type of trail mix X, the other type of trail mix Y. We'll have that be 30. Then we're going to write an equation for the cost. Well, we'll say the first trail mix is going to be $2.45 plus $2.30 equals $2.35. Now, this can't be $2.35. We're going to multiply that by 30. We did problems like this in class, but just as a review, the first one we multiplied by 245. My second was multiplied by 30, so my total has to be multiplied by 235 because we're going to mix them together. And as we can see, since it's 235, I should have more of the second one, shouldn't I? But here's the nice thing. I can actually, well, let's do this before we type it in to decimals. Let's simplify. So I'm going to rewrite my second equation as 245x plus 230y. Let's take 30 times 2.35. And let's get a new graph here. Because if I take 30 times 2.35, I get $70.50. You could have just typed that in, but I'm going to write it like this. So now let's graph these two. Let's go x plus y equals 30. Whoops, I want my graphing one. So x plus y equals 30. My second one is going to be 45x. Let's go back and double check that. 245x plus 230y. I don't really need the zero there, but since we're talking money, I'll just put it in. Equals, and what did we say that one was? We said that was $70.50. And you don't see any graphs here because they're off your graph. There we go. Now, they intersect at 10 and 20, don't they? Don't just write 10 and 20 because it's an application problem. You have to write answer in a complete sentence. So we're going to say 10 pounds at 245 and 20 pounds at 230. And like we said, we knew it was going to be more. We knew it was going to be more of the 231 because it was closer in price to that one. And number 17. Hey, if you want to try 17 by graphing, good luck to you. Because this one I put on here to make it hard to graph, to show you that there are some questions that it is not best to graph on. Because you might be thinking at this point, hey, can't I graph for all my problems? Here is a perfect example where substitution is the easiest way to do that. It's because on this problem, rather than telling you certain information, what I told you was the end part, which makes the problem easier to do by substitution. And what happens is it says the speed of boat in still water is 15 miles greater than the current. So in other words, if I write this out, my speed of my boat in still water is going to be 15 miles plus the current. Now, how about if you're going against the current? Well, if you're going against the current, you're going to have the speed of the boat in still water minus the current. In other words, still water is 15 plus C minus the current, which is C. So in other words, on this problem, on other problems we did like this, I actually told you the current and you had to find out what the speed was. But in this case, you know your speed going against the current is 15 miles per hour. So in other words, we can do that. And let me see, a boat travels 60 miles downstream. I want to find the speed of the current. Now, what I'm going to do on this problem, let's go against the current. So 36. So my speed, or my distance going against the current, is 36 miles per hour. I'm going to do distance equals R times T. So in other words, 36 equals my speed, which is 15, times T. I'm going to divide by 15. So T, since I'm doing an application problem, I think I'll write that as a decimal. So we'll take 36 divided by 15. And that is 2.4. Now that doesn't answer a question, does it? So now we have to go with the current. Now my speed with the current is going to be the speed in still water plus the current, or 15 plus C will be 15 plus 2C. Let's see there. Okay, so now we'll do distance equals rate times time, only we're going with the current this time. So with the current, I'm going to go 60 miles, and I know my speed is going to be 15 plus 2C. And the nice thing is I know that my time is 2.4. So now I've just got one variable. So notice we use substitution all the way throughout here. So in other words, 60 equals 15 times 2.4. We'll distribute that. So 15 times 2.4 is 36. Oh, we've seen that before, haven't we? Plus 4.8C. C isn't showing up there. So a minus 36 from both sides. 36 minus 24 is 10 minus 6 is 4. 5 minus 3 is 2. So 24 equals 4.8C. So to solve for C, I'll divide both sides by 4.8. So 24 divided by 4.8. And 5. So C is 5. And since we are doing an application problem, don't forget the units. 5 miles per hour. Maybe I'll write it here in a different color. It's a little harder to see. Okay. Would be your speed of the current. That's, I think, the most challenging problem we have on the practice test. I don't think you have one quite as complicated on the real test, but if you do, we've just gone over one like it. So remember, sometimes it's easy to use substitution.